All right, so today we're talking about solving exponential equations. And exponential equations are equations where the x is your exponent. So here is your example number one. I have 2 to the x is equal to 16. And here you have to think, oh man, that means 2 times itself, how many times gives you 16? And if you don't know that off the top of your head, there's a way to do it, right? So you can just break 16 down. And by the way, I know some of you guys can just do it off the top of your head, right? You know 2 times itself, how many times can give you 16. But if you don't know, we just break it down like this. So 16 gives you a bunch of 2's, and that's great. It works, So 2 to how many? 4. 2 to the fourth is equal to 16, something like that, right? So x is equal to the fourth power. Um, Now, if I were to ask you 3 to the x is equal to 16, oops, 16. That's going to be very hard to do, right? Because you break 16 down, you don't have threes. So that's going to be something that's going to require a little bit more work to do. And actually, you need a calculator to help you because we can't really do it. It's irrational, and our mind cannot come up with irrational numbers. You actually can't do it. So that's another story, but that's what an exponential equation is. Okay, when it gets a little bit harder, we have to do it more systematically. Okay, so let's try example number 2. I have 2 to the x minus 10 is equal to 8. So basically, you have to figure out 2 to the what gives you 8, right? So I'm going to break it down. Okay, so 2 to the x minus 10. I'm going to leave that there, but I'm going to break the 8 down. So 8 is actually 2 times 2 times 2, right? So that gives you 2 to the third power. So the whole point is, guys, if you can make this base the same on both sides of the equation, you can solve for it. If the bases are the same, you can just assume that the exponents have to be the same. Okay, once you get the bases to be the same, you set up the exponents to be the same, and you get x minus 10 is equal to 3. Oh, I did that already. So you just solve for that. You add 10 to both sides, and x is equal to 13. And let's see if that really makes sense, okay? You look back here, the original equation. You put 13 there. 13 minus 10 is 3. 2 to the third power is 8. So that's how it works, okay? Let's do a couple more. I have example number 3. I have 2 to the 2x, is equal to 1/8. All right, so now this one looks all crazy and confusing because it's 1/8. So I'm going to leave this here, and I'm going to work with this guy. So 1/8, if you remember the negative exponent, that's what it does. Negative exponent means you flip it to the other side of the fraction, right? So 8 to the negative first power is 1/8. Right? So that's how it works. So if you see like a number at the bottom, change it to a negative exponent, and it actually goes back to the top. So here, let's just leave that there, and then I want to change the 8 into the 2/3 power, right? So I'm going to leave this the same. So 2 to the 2x is equal to, now all I'm doing is I'm changing the 8 into 2 to the third power because we knew that from the last example. So here I have that. All right. And then I want to keep that the same. Here, what you want to do is you want to multiply these exponents because that's a property of exponent that you should have learned. Okay. The power rule. So that gives you 2 to the negative third power. And then, so the bases are the same, right? Now I can set up my exponents to be the same. So 2x is equal to negative 3. And you solve for that, you get x is equal to negative 3 halves. Okay, that might have been confusing for some of you. So I want to say that one more time. If you have something at the bottom of the fraction, all you have to do is make the exponent negative, and it goes back to the top. And then you do the same step. Just change it so that the base is the same. Break that number down. Okay. I want to do another one. So you guys can get better at this. I have 9 to the 2x minus 1 is equal to 27. Okay, so if I break 27 down, I'm going to have 9 times 3. Okay, so I don't have 9 to a certain power. It's 9 times 3, so that won't work. So I'm going to break the 9 down some more. I have 3 times 3 times 3. Okay, so I have 3 to the third power is 27. And here I have 9 to the 2x minus 1. So I'm really struggling to make these bases the same. So what I have to do is I have to break the 9 down also. Right? Hopefully the 9 can give me 3s. And it's true, 9 gives me 3 times 3. So I'm going to change that 9 into 3 squared. Raised to the 2x minus 1 is equal to 3 cubed. And then I'm going to multiply my exponents, right? If you have exponent of exponent, you multiply. Just like over here, you times -1 and 3. Here you multiply these two. So I have 3. To the 2 times 2x is 4x. And then 2 times -1 is -2. Equals to 3 to the third power. See, now the bases are the same. I can just set the exponents to be the same. So 4x minus 2 is equal to 3. Plus 2, 4x is equal to 5. X is equal to 5/4. All right, I have 2 more examples for you guys here. Example 5, I have 5 to the 4x minus 1 is equal to 1 over 625. All right, there's that trick that we did earlier, right? 4x minus 1. If it's at the bottom, you just make it 625 to the -1, and now it's on the top. And then now I'm going to change that. If I break 625 down, I actually have 5 times 125, which is 5 times 25, which is 5 times 5. There you go, that's not bad. And then, so I have 5 to the 4th power, and that's still to the -1, and here I have 5 to the 4x minus 1. So the bases can be the same now because it's just 5. But here, this is 5 to the, remember, multiply your exponents, so I have -4. So now the bases are the same. I can set the exponents to be the same. So 4x minus 1 is equal to -4. So 4x is equal to -3. X is equal to -3/4. All right? Let's see. Erase this side here. Erase. Erase. Just erase the whole thing. Last example. They can give you like a slightly harder kind of problem. Strange. So they might give you like 49. 4 minus 9x is equal to 7x squared minus 26x plus 15. Something like that. So here the bases, I got to break them down to make them look the same, right? So I'm going to break the 49. That is 7 times 7. So I have 7 squared raised to the 4 minus 9x is equal to now 7 to the blah, 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 blah over here. So now the bases are the same, right? So I want to multiply these guys here. So I have 7 to the, let's see, 2 times 4 is 8. Minus 2 times 9 is 18x is equal to 7 to the x squared minus 26x plus 15. So bases are the same. I could just have 8 minus 18x is equal to x squared minus 26x plus 15. Now I can solve for that. Here, the only difference is this quadratic, so I have to make everything equal to 0, right? So I add 18x here, and then subtract 8. I have 0 is equal to x squared minus 8x plus 7. And now I can solve for that, factor that out. I get x minus 7, x minus 1 is equal to 0. So, and then you solve that x is equal to 7 or x is equal to 1.